Hey everyone, welcome back. What if everything you think you know about the Earth's core is completely wrong? Imagine a hidden world, right beneath your feet, churning with these insane forces that are secretly pulling the strings on everything happening up here. By the end of this video, you're gonna look at the ground in a whole new way, like it's an angry, sleep-deprived giant. And yeah, you'll definitely stop thinking of solid as a rock as some comforting phrase. Today, we're counting down the most disturbing truths about our planet's fiery heart. We're talking, why is it so ridiculously hot? How it can mess with earthquakes and volcanoes? What kind of bizarre stuff might be sloshing around down there? And, maybe the scariest part, why the magnetic shield we all depend on is less trustworthy than your phone's autocorrect. Alright, let's get into it. Number 10. Not just hot, it's a pressure cooker. So, you know that classic movie line, hotter than the surface of the sun? Well, it sounds like total clickbait, but it's also kinda true, if you squint. See, the inner core is thousands of degrees. We're talking estimates that put it right up there with the surface of the sun. Not the sun's core, obviously, but still. But here's the kicker. It's all about the pressure. Down there, the pressure is literally unimaginable, and under that kind of squeeze, iron starts acting like something straight out of a sci-fi movie. It's crushed, it's crystalline, but it's still giving off all this heat. So yeah, it's ridiculously hot. But it's the combo of that heat, plus the insane pressure that makes all the weird physics happen. Here's the short version. It's not swipe right hot like a sunspot. It's crushing you into a diamond hot. It's pressure hot. Number 9. You don't just have layers. You have a living, shifting heart. Alright, first things first. Forget that neat little diagram you saw in high school. The Earth's core is not some perfect, tidy onion. The reality? Seismic waves show us it's a lumpy, messy place down there. We're seeing giant hotspots, weird blobs, and all sorts of anomalies. Massive features that are actually wiggling and drifting around over millions of years. And get this, right at the boundary where the core meets the mantle, you've got these bizarre plumes that act like massive, super slow motion weather systems. It's like the core and the mantle are constantly talking to each other. And their conversation? It happens in the language of earthquakes and tremors. The bottom line is, the deep earth is anything but static. It's constantly on the move. So forget tranquil compost heap. The planet's center is way more like a moody oven with really spotty Wi-Fi. Number 8. Seismic weirdness. Nature's deep earth email you can't open. So, how do we see what's happening down there? We use something called seismic tomography. But the pictures we get back? They're grainy. And a lot of the time they don't even make sense. They totally contradict each other. Lately, scientists keep finding these weird anomalies. We're talking about earthquake waves that show up too early or too late, or bounce off things that shouldn't even be there. All these clues are hinting that things are actively changing deep inside the planet. It's like one minute an area looks super dense, and the next, it seems way lighter. We're even starting to think that major earthquakes can be a warning sign that a big, long-term shift is about to happen. Now, this isn't stuff you'll see on the nightly news, but it all points to one thing. Deep down, the Earth occasionally just flips a hidden switch. So here's the best way to think about it. The Earth is sending us cryptic emails written in Morse code, and we've barely figured out how to read the subject line. Number 7. The unseen architects of catastrophe. Okay, so we always blame tectonic plates for earthquakes and volcanoes, right? And yeah, that's fair. But what if the real puppet master is deep down in the core? Picture this. A huge plume of super hot material shoots up from the edge of the core and slams into the plates above. That puts a ton of stress on them. We're not talking about regular volcanoes here. We're talking about the kind of massive eruptions that create supervolcanoes and can literally rearrange an entire region. And get this. Scientists have linked some of the biggest mass extinctions in history back to these exact kinds of deep Earth events. Even today, new models suggest that the slow growth and movement of the inner core could be putting long-term stress on the surface. Now, this isn't something to panic about tomorrow, but over thousands or millions of years, a cranky core can absolutely change the game up here. So, the punchline is this. The tenants living in Earth's basement can sometimes throw a party so loud, it brings the whole house down. Number 6. The inner core might not be as solid as you think. You know how textbooks always call it the solid inner core? Well, solid doesn't even begin to cover it. Down there, under all that pressure, iron gets weird. It's not just a solid chunk. It can be crystalline, sure, but it can also be kind of mushy, or even flow like the world's slowest, thickest honey. And the clues we're getting from earthquakes are wild. Some studies suggest the inner core is actually spinning at a slightly different speed than the rest of the planet. Others hint that there are slushy, partially melted zones down there. They've even found that it has a grain to it like wood. where seismic waves travel faster in one direction than another. And here's why that matters. If the inner core is more of a patchy, lumpy mess than a perfect solid ball, then the entire engine generating our magnetic field, the very thing protecting us from solar radiation, could start acting erratically. It might get weaker or shift in ways we just can't predict. So, forget the idea of a perfect gold-plated marble. The real picture is more like a slow, awkwardly dancing blob. Number 5. The core's toxic secrets and weird chemistry. So we're all taught the core is just molten iron and nickel, but it's way more interesting than that. Scientists are pretty sure there's a whole cocktail of lighter elements mixed in down there. We're talking sulfur, oxygen, maybe even hydrogen. Under that insane pressure, you get these bizarre metal alloys that probably don't exist anywhere else in the solar system. Some theories even propose there are pockets of radioactive material dotted throughout the core, acting like little extra hot furnaces that mess with the heat flow. And here's a really wild, controversial idea. What if the core is slowly leaking chemicals up to the surface over millions of years? A process that could subtly change everything from the chemistry of our oceans to our long-term climate. Now, a lot of this is on the cutting edge, and nobody's 100% sure. But the main takeaway is this. The core is not a pure, simple iron ball. It's a complex, messy chemical soup. Which leads to the perfect punchline. Think of the core's pantry as being stocked with a bunch of weird spices you never ordered, and can absolutely never return. Number 4. Magnetic meltdown. The shield is weakening, and that's complicated. You know that magnetic shield protecting our entire planet? It all comes from the geodynamo. Basically, a massive, churning ocean of liquid metal in the outer core that generates our magnetic field. But here's the thing. That shield is showing some cracks. We know the field has been getting weaker over the last century, especially in certain hotspots like the South Atlantic anomaly. Now, this isn't an end-of-the-world tomorrow scenario, but a weaker shield means more harmful radiation from the sun, and deep space can get through. That's bad news for astronauts, bad news for our satellites, and it can seriously mess with all the electronics we rely on. But the really scary part? The field doesn't just get weaker. Sometimes it flips. I'm talking about a full-on pole reversal. North becomes south, south becomes north. It's happened a bunch of times in Earth's past. And while the flip itself takes thousands of years, during that messy transition, our planet's compass goes haywire, and radiation levels could spike until the new field finally locks into place. So, to put it simply, your little fridge magnet will be just fine. Your billion-dollar satellite, on the other hand, might have some notes. Number 3. Solar storms, plus weak shield-equal technological nightmare. Alright, number 3 on our list. Solar storms, plus a weak shield equal a technological nightmare. So we've talked about our weakening magnetic shield. Now what happens when you throw a massive solar storm into the mix? You get a recipe for absolute disaster. We're talking about a huge blast of energy from the sun, a coronal mass ejection slamming into Earth. When that happens, it can trigger a geomagnetic storm that overloads our entire infrastructure. It can fry power grids, melt transformers, and completely wipe out communications. And this isn't science fiction. We've seen it happen before. Just look up the Carrington event of 1859. It was so powerful, it set telegraph offices on fire. Now imagine that same storm hitting us today, but with our magnetic shield already weak or worse, in the middle of a flip. The risk goes through the roof. This isn't some Hollywood asteroid movie. This is a real plausible threat that our modern world is dangerously unprepared for. Which brings us to the punchline. The sun already seems to hate our Wi-Fi on a good day. We really don't want it to escalate things. Number 2. Monitoring the deep. We're getting better, but it's messy. So, if the core is this mysterious churning beast, how do we know any of this stuff? We obviously can't just drill down there. So we have to get creative. We have to improvise. It's like a huge detective case. First, we listen to earthquakes. Seismic networks across the globe let us map the inside of the planet. Then, we have satellites up in orbit, constantly tracking tiny changes in gravity and the magnetic field. Meanwhile, in labs, scientists are using things like diamond anvils to literally squeeze materials until they mimic the insane conditions at the core. And of course, we run massive computer simulations trying to figure out how the whole thing works. The tech is getting better all the time. We're now using things like geo-neutrino detectors, literally catching ghost particles from deep inside the Earth, to get clues about all the weird, lumpy, and patchy bits down there. The amazing part is that teams all over the world are finally starting to knit all this different data together. But the picture we're getting? It's still super fuzzy. And honestly, it's full of more questions than answers. Which really just leaves one way to describe the scientists doing this work. They're like forensic geologists, piecing together a mystery with a tiny magnifying glass and a whole lot of patience. Number 1. What if the core is quietly rewriting Earth's future? And all of this brings us to the big disturbing takeaway. It's this: a tiny change deep in the core, a slight shift in the flow of liquid metal, a little burp of extra heat, can set off a chain reaction. That chain reaction, over millions of years, can completely change the game on the surface. We're talking about altering plate tectonics, triggering massive volcanic events, and messing with the magnetic field that protects us all. Yeah, these things happen on geological time, not overnight. But these are the very processes that have shaped everything. They set our long-term climate, they're linked to the mass extinctions we see in the fossil record, and they control the stability of the very environment we need to survive. The hard truth is that the real drama of our planet is slow, hidden, and has massive consequences. We are living on the surface of an engine that we're only just beginning to understand. And maybe the scariest part? The Earth's warranty card basically says no returns, and in the fine print, subject to internal misbehavior. So what does all this actually mean? And what are you supposed to do with this information besides, enjoy a healthy dose of existential dread? Well, believe it or not, there are some real takeaways here. First, we need to get serious about funding the science to monitor all of this. That means more satellites, better seismic networks, and smarter computer models. This isn't some sci-fi fantasy. This is critical infrastructure for our planet. Second, we need to make our systems tougher. That means building smarter power grids that can handle a major solar storm, having backup satellites ready to go, and better shielding for all the tech flying over our heads. It's about making ourselves less fragile. Third, we need better early warning systems. Not just for the fast stuff like earthquakes, but for the slow burn threats, like space weather and other geological hazards that build up over time. And finally, on a personal level, stay skeptical, but stay prepared. Don't fall for the crazy core apocalypse headlines, but at the same time, respect that there's a lot we don't know. Being prepared is just cheap insurance. Alright, that's it from the center of the Earth for today. If you enjoyed having your entire sense of solid ground completely unsettled, do me a favor and smash that like button. And if you want more deep dives into the weird hidden engines that actually run our world, make sure you subscribe and ring that bell so you don't miss a thing. Thanks for watching, and I'll see you in the next one.